Hello everyone and welcome to another episode of Investigation. In today's episode of Investigation, I will use Zeno's paradoxes to solve geometric series, which is summations of geometric sequences. And specifically, we're gonna use the paradox of Archimedes and the tortoise. So let's get started. First of all, let's introduce the paradox. The paradox states that in a race, the quickest runner can never overtake the slowest, which is obviously false, since the pursuer must first reach the point whence the pursuit started, so that the slower must always hold the lead, no matter how small it is. Well, we know that is false, but why that is? We're going to prove that in this video. So let's go over an example provided in the paradox. We know that Archimedes is in a foot race with a tortoise. Obviously, Archimedes is faster, and he allows the tortoise a head start of 100 meters. Say that the Archimedes runs 10 times as fast as the tortoise. Let's see if he can eventually chase up to him. And here is the number line that I created. Here is him and the tortoise. Give him a 100-meter head start. Well, the problem is that for him to catch up to the tortoise, he must run the first 100 meters first to catch up to the starting point of the tortoise, which then the tortoise runs 10 meters. When he tries to catch up that 10 meters, the tortoise runs 1 meter, so on and so forth. When he runs 1 meter, the tortoise runs 0.1 meters, so he can never catch up, right? Well, obviously that is wrong. And this is the paradox. And let's do some assumptions first. To make the calculations easier, we can assume that the speed of the tortoise is 1 meters per second, so his speed is 10 meters per second. And here comes the geometric series. The first period that he uses is 10 seconds because he uses 100 meters and the tortoise goes 10 meters, and that is 100 divided by 10, which is 10 seconds. Now he's only 10 meters behind. The second period is when he runs 10 meters and the tortoise only runs 1 meter, and the time is 1 second. So on and so forth, but the sequence goes on infinitely, and the conclusion is that the Archimedes can never chase up to the tortoise, which is obviously false because we can construct a geometric series 10 plus 1 plus 0.1 plus 0.01, so on and so forth, but we know that since the common ratio is less than 1, we know that this sequence does not go to infinite, and there is actually a definite answer for this. So we want to solve this, right? But we can think of this in a different way, where we can think of this as for every second that passes, he chases 10 minus 1, which is 9 meters up. And that the total time he needs to catch up is 100 divided by 9 meters. So that is 100 over 9 seconds. And so we can conclude that this sum of geometric series, infinite geometric series, is equal to 100 over 9. So 10 plus 1 plus 0.1 plus 0.01 plus so on and so forth, go on infinitely, is equal to 100 over 9. And we can list another example. This actually works for every single geometric series. Let's say we want to find the value of 1 plus 1/2 plus 1/4 plus 1/8, and so on and so forth, this infinite geometric series. Since the common ratio is 1/2, we can assume that the Archimedes is twice of that tortoise, the speed of Archimedes. And we can assume that velocity of Archimedes is 2 meters per second, the velocity of tortoise is 1 meters per second. And for the first period, Archimedes uses 1 second to chase to the location before the tortoise started. And this 1 second comes from the first term in the geometric series. We can reflect on that and see that 1 second, since his speed is 2 meters per second, we can conclude that the head start of the tortoise is 1 times 2, which is 2 meters. And that he uses 1/2 second to chase the location after the tortoise first period, and 1/4, and so on and so forth. And the total time he used to chase the tortoise is 2 divided by 2 minus 1, because every second that passes, he chases 1 meter. That 2 divided by 2 plus 1 is 2. So we can conclude, after all, that 1 plus 1/2 plus 1/4 plus 1/8 is equal to 2. And we can generalize this, and that is for geometric series a plus ar squared with r between 0 and 1, that we can assume that his speed is 1 over r meters per second, and the tortoise speed is 1 meters per second. Because r is less than 1, we want the Archid's speed to be faster, and 1 over r is faster. And then he will use a seconds to chase the tortoise to the tortoise's starting position, which means that the tortoise had a head start of a times 1 over r, which is a over r meters. Thus, we can conclude that a plus ar squared plus so on and so forth is equal to a over r divided by 1 minus r minus 1. 1 minus r minus 1 is simply equal to the every second that passes, Archid's chases 1 over r minus 1 meters. And we can multiply by r on both sides of the fraction, and we get that is equal to a over 1 minus r, which is our answer for every single infinite geometric series with r between 0 and 1. But let's reflect. Why do we need to make sure that r is between 0 and 1? Well, that is because we want the Archid's speed to be faster than the tortoise, so he can eventually chase up to him. Imagine that r is greater than 1, then we have Archid's speed is slower than the tortoise, which means that he will never chase up to him. So, for geometric sequence with that property, if you want the sum of that, that would just result in infinite, because he can never chase up to him, and the t is just equal to infinity. Well, we can generalize this, and we can actually extend the range for it to actually become -1, less than r less than 1, because -1 to 0, although it is not concluded in the paradox, it still works, and it is the sequence, if you think about it, is still shrinking, which means our answer will not be infinity. Thank you for watching this episode of Interstigation, and I will see you in the next one. Goodbye.